Good evening, sir.
Yeah, good evening. I will start the session 5-10 minutes later so that some more students can join.
Okay, sir.
Hello, am I audible and is my screen visible? Can anyone please let me know?
Yes, sir.
Yes, sir.
Yes, sir.
Hello, boss.
Okay, thank you. Yes, so good evening everyone. Welcome to this NPTEL live session for the NPTEL course Introduction to Machine Learning. My name is Ayan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my first live session in this offering of this course. In this live session we will discuss and solve some practice problems on week 1 topics. In week 1 mainly some introductory topics on machine learning were covered, like supervised learning, unsupervised learning, regression, classification, reinforcement learning. So these were the topics that were covered in week 1, and we will see some practice problems on these topics which will help you to solve the assignment questions for this week. And Jitendra, do you have something to say?
Nothing, sir, nothing.
Okay, then please keep your microphone into mute so that it doesn't disturb the others. Thank you.
Hello, sir.
Yes.
One of my friend is not able to join. Only 100 people.
There is a lot of echo coming from your side.
So one of my friend is unable to join because this meeting only allows 100 participants.
Yeah, that I cannot do anything about. Yeah, in Google Meet there is a restriction on how many participants can join, so it cannot exceed 100. So unless someone leaves the meeting, your friend cannot join. There will be many such students who would be trying to join this meeting, but I cannot do anything about that because Google Meet has this limitation. Also, I'm recording this meeting and this session, so I will upload this session in YouTube, and the links will be provided to all of you from NPTEL. So even if you miss a session, it's not a problem. You'll be able to watch those recorded sessions in the YouTube.
Okay. Thank you.
Also, these materials, that slides that we're using, questions that we are solving, we will also upload these PDFs, and NPTEL will provide all these links to all of you maybe in 1 week or so.
Okay. Thank you.
Hariharan is asking, did you upload the recorded sessions of the past 2 classes? This is the week 1 live session for me. So this is the first live session that I am conducting for this course in this semester. Okay, so and also if you have any questions or doubts regarding these week 1 topics, you can feel free to ask me. So first we will start solving the practice problems, and after that, if you have any questions or queries regarding any of the questions that I solve or any of the topics covered in week 1, you can ask me. Okay, so these are the logistics of my live sessions. Every Monday I will conduct these live sessions from 6 p.m. to 8 p.m. There are other TAs who are also conducting live sessions every week. Different TAs have different timings. So my live sessions will be held every Monday, and this is the link to join. So this is the first question. Which of the following are supervised learning problems? Multiple options may be correct in this question. So there are 4 options: learning to ride a bicycle using a reward signal, predicting disease from blood samples, grouping students in the same class based on similar features, and face recognition to unlock your phone. And you can write your answers in the chat. So multiple options may be correct in this question. Bapi Saha says option B, Maris Ganesh says B and D. Bhaskar Sahu says B. Subrangshu Mohanty says B and D. Shweta says B. Sarvanan Natarajan says B and D. Bapi Saha says B. Saksham Chawla says B and C. Katkuri Venu Vardhan Babu says B. Diya Raghuvang says B, C, D. Ansvardhan says B. Utkarsh Pratap Singh says B, C, D. Muhammad Arif Ali says B, D. Yeah, so most of you are saying B and D. Some of you are also saying B only. Akshay Kumar says A, B, D. Juhi Sharma says B and D. Saurav Sahgal says B. Okay, most of the answers in the chat are B and D. Some of you are also saying A or C also. Anantapalli Naga Lakshman Kumar says B and D. Okay, so most of the answers are B and D. So the correct answers are B and D here. So you have to go through each of the options to analyze whether a certain option is supervised learning problem or not. So the first option says learning to ride a bicycle using a reward signal. So this is a classic example of reinforcement learning where someone has unmuted, I think. Please mute yourself. Yeah, thank you. So the first option is an example of reinforcement learning, that the environment provides you some reward signal, and by this trial and error and the reward signal you learn. So this is not a supervised learning problem, learning to ride a bicycle. Second option is predicting disease from blood samples. So in case of predicting disease from blood samples, so it is a supervised learning problem because you need to have the class levels or the Y values for each of the blood samples, otherwise you will not be able to train the algorithm. So that is a supervised learning problem. So option B is a supervised learning problem. Option C says grouping students in the same class based on similar features. So any kind of grouping or clustering problem is an unsupervised learning problem, because here you don't have the those Y values or the class levels or the target variables. You just group the samples, in this case students, based on similar features, or cluster them based on similar features. So that's why option C is not a supervised learning problem. It is an unsupervised learning problem. And the last option, face recognition to unlock your phone. So this is also a supervised learning problem, because the phone needs to remember which is your face and which is not your face. So these class levels, whether a certain face is yours or not, so that data needs to be recorded. So that class levels are needed. So it is a supervised learning problem. So B and D, these are the two correct answers.
Excuse me, sir, I have a doubt here.
Yes.
Why not C? Because C is also label. Learning, supervised learning means you have to have a labels for right?
Yeah. So in supervised learning problem, the training data that you will have, that should contain those class levels or the target variables or the Y values that we call. But in case of grouping or clustering, we don't get those class levels in the training data itself. We try to cluster them or group them based on the input features. We don't have the actual class levels. So that is unsupervised learning problem. So in unsupervised learning, we don't have those Y values, but based on the similar features of different samples, we try to group them, that these samples are similar, so this is one cluster. These samples are quite similar, so this is another cluster. That way we group them, but the actual Y values or the target variables are not given to us.
Why labels are not given? You mean to say why labels are not given?
Why, grouping basically means that you are not given any
labels are input labels are not given, I mean to say, because similar features is given, not exactly represent the features.
input features are given, which is this x and y. So I hope you understand this nomenclature, x and y. X contains those features for every data point, and y contains the target variable, whether it might be continuous for regression, it might be classes for classification. So these y values are not given in case of clustering or grouping problems which are unsupervised. Based on these y values, we try to group the similar samples into one cluster. In case of B and D, so to predict a disease, we have to have these y values, otherwise how can we predict whether certain blood sample is certain disease or not. Similarly, for face recognition, we need to have these y values, otherwise how will your phone know whether this face is your face or not. So these y values are given needed in case of face recognition also. So B and D are the two correct options.
Okay, thank you, sir.
Yes. Moving on to question 2. Which of the following are classification problems? So in the previous question we talked about supervised learning problems. In this question you have to find out which of the following are classification problems. Again, multiple options may be correct. There are 4 options: predict the price of a house, predict the disease of a person, predict the temperature for tomorrow, learn to play a guitar. You can write your answers in the chat again. Tejaswini Teju is asking, can you tell us from where to access the recording link classes? Yes, so I am recording these classes and I will upload these classes in YouTube, and then the links will be provided to all of you by NPTEL. You will get those links in the course web page. On the left hand side you will have those course materials, week 1, week 2, week 3. There you will also have another tab. It is not yet created, it would be created by NPTEL team. Live sessions, from there you will get all those recordings. In a few days NPTEL will create that tab and share with all of you.
Sir, I have a small doubt.
Yes.
So is the question asking us to find the disease of the person or whether the person has the disease or not?
I mean, in both cases, you either for a single disease, whether the person has disease or not, that can also be one way of thinking, and the other is there are several diseases that you want to predict in the problem. I mean, obviously
Yes, sir,
finite
so
number of diseases, not
if
infinite.
there are, okay, sir. Yes, sir. Got it.
Yeah, there are finite number of diseases, let's say 3 or 4 that you want to predict, or only one disease, whether that person has that disease or not.
Sir, option C, predict the temperatures for tomorrow. It's a real value or continuous values, or it's going to be high, low, or like that. It's going to
No,
be like
it would be real numbered values. So Subhrangshu Mohanty says option B, Bhaskar Sahu says B, Anantapalli Naga says B, Nisrin Dundia says B, Sarvanan Natarajan says none. So most of you are saying B, some of you are also saying A. Satish Singh says A and B. Utkarsh Pratap Singh says A and B. Niranjan Murthy, Mohammad Arif Ali, Sarvajan Natarajan says B. Vapi Shah says B. Sanvi says A, B. Mohammad Abdul Kader says A, B. Maris Ganesh says B, C, D. Yeah, most of the answers in the chat are B. Namish says C, D. Yes, Mehratra says B if limited value for diseases, else none. Yeah, the disease is either one disease you are predicting 0, 1, or a several number of finite number of diseases that you are predicting.
Yes, sir. That's what that if the diseases are limited of 2 or 3, then it will be a class
It is certainly
regression.
limited. It is a finite number of diseases that you are predicting. Krishna Varanasi says B. Akula Sangita says C. Okay. So the correct answer here is option B only. So most of you have gotten it right in the chat. So first option says predict the price. So in case of classification problems, so supervised learning problems are divided into two types: classification and regression. In classification, the output variable or the y values consists of only a finite number of classes or class levels, 0, 1, 2, 3, like that. Finite number of classes would be there. And in case of regression problems, the output variable should be continuous variable within any given range. It can be from minus infinity to infinity, or 0 to infinity, or a specific range, but the output variable or y values should take continuous values. So in this question we are asking classification problems. So first option says that predict the price of a house. So price of a house is a real numbered value. So certainly it can be anything from 0 to infinity. So this cannot be a classification problem. And option B says predict the disease of a person. So disease, either one disease, you are predicting 0, 1, that is whether that person has that disease or not. So that can be a classification problem. And if there are finite number of diseases, 2, 3 diseases that you are predicting whether a person has a certain disease or not, that is also a classification problem, because each disease is a class. So there will be finite number of classes. So option B. Option C says that predict the temperature for tomorrow. So temperature can take any value, any real numbered value. So this cannot be a classification problem. This has to be a regression problem. And option D says that learn to play guitar. So this is using the principles of reinforcement learning. So you cannot learn this by classification. So this is also not right. So the only correct option is option B. Is there any doubt in this question? Hariharan says option D is RL. Yes, so option D is a reinforcement learning problem. Learning to play guitar, learning to drive, learning to ride a bicycle, all these are generally thought of as reinforcement learning problems. Okay, so we can move on to the third question. Question 3. Which of the following is not a categorical feature? So different features are given, like area of a house is a feature, height of a person is a feature, like this. And you have to find out which of the following is not a categorical feature. Multiple options may be correct again. So 4 options: area of a house, height of a person, types of mountains, nationality of a person. Saravanan Natarajan says CD, which is types of mountains and nationality of a person. Subhrangshu Mohan says A.
Sorry, sir, A and B is sorry, I've given it wrongly.
Yeah, it is not a categorical feature. So please mind whether not is given in the question or not, whether it's not a categorical feature or is a categorical feature. And yes, Mehrotra says C, Narmada says C, Nisrin Dhundia says AB, Sanvi says C, Tamil Selvi says AB, Mounes says C, Dia Raghuvang says C, Yes Mehrotra says AC, Bapi Saha says AB, Hariharan says AB, Muhammad Abdul Qadir says AB. Okay, many of you are saying AB and many of you are also saying CD. So the question is not a categorical feature. So correct answers are A and B. So categorical feature is a feature in which can be divided into several categories. So Option A says area of a house. So this the area of a house, this feature doesn't have several categories. It is a continuous variable from 0 to infinity. It can take any value. So this is not a categorical feature. Height of a person. This is again a continuous feature. So this is this cannot be divided into categories. So this is also not a categorical feature. Option C is types of mountains. So types of mountains, there are only several types of mountains. Specific finite number of types of mountains are there. So and those are can also be said as categories of mountains. So those are different categories. So this is a categorical feature. Option D says nationality of a person. Again, we can have only several finite number of categories of nationalities. So this is also a categorical feature. So the question is not a categorical feature. So A and B, these two features are not categorical. These are continuous features. You cannot divide them into categories.
Sir, excuse me, sir. Repeat once again that area of house, sir.
So
It is
area of a house can take anything from 0 to infinity value, isn't it? So square feet is the unit. So from 0 square feet to any 100 square feet, 1000 square feet, the value can take any real numbered value. This feature can take any real numbered value. So you cannot divide into specific categories. Similar to height, it can go from 0 centimeter to 200, 300 centimeter, anything it can take.
okay, sir. I thought that it's the area meaning of location. I thought that.
No, area means the floor area of that house. Yeah.
Okay, sir. Thank you, sir.
Sir, having doubt in option B.
Yes.
Having doubt in option B.
Option B, I mean height. Height is a continuous feature.
Sir, height can be limited to or 8 or 10 because a person cannot have a height to infinity.
No, it doesn't need to be to infinity. It can be from, let's say, 60 centimeter to let's say 200 centimeter. So that is also continuous value, isn't it? It can take infinite number of values from 60 to 200, isn't it?
Okay.
It can be any real number of values, 60.1, 60.0009, it can take any value. So you cannot specifically divide this feature into specific categories, finite number of categories, you cannot divide.
Okay.
Muhammad Arif Ali says, is classification and categorical same term? So classification is a problem, type of problem that in classification problems you are asked to predict the class of a specific input value, and categorical is for features. A certain feature can be categorical or not categorical or real numbered. So those two are not exactly same things. Classification is for problems, whether a problem is classification or regression problem, and whether a feature is categorical or not. So those two are not exactly same. Grishma is asking, can you please repeat the concept? So I will I'm recording these sessions and I will also upload these sessions in YouTube, so you can always go back and check the same recordings of the live sessions there in YouTube if you don't understand completely, or if you have missed some of the previous questions, so you can again go back to YouTube and check it. Shweta Lakshmi says, do we have to attend all 4 sessions? No, I mean there are 4 sessions in every week, so that all students can join. So every student cannot attend a specific timing, so that's why there are 4 different TAs for 4 different live sessions. You can join any 1, 2, 3 or all 4 if you are free.
Thank you.
So question 4, which of the following tasks is not a suitable machine learning task? There are 4 options: finding the shortest path between a pair of nodes in a graph, predicting if a stock price will rise or fall, predicting the price of petroleum, grouping mails as spams or non-spams. not a suitable machine learning task. So all of you are writing option A. Rishi Raj Pandis is option C. So one option C I can see, others are writing option A mostly. Maris Ganesh is option C. Ansvardhan Singh Sholankis is option B. Okay, so most of you are saying option A. Option A is the correct answer. So finding the shortest path between a pair of nodes in a graph. So those of you who have studied computer science, they would know that it is generally comes under graph theory related algorithms. Different algorithms are there like Dijkstra, Bellman-Ford. These algorithms are there to find shortest path between any pair of nodes in a graph. So machine learning is not really suitable for this task. It would be much more expensive than the other already well established algorithms like Dijkstra, Bellman-Ford. So machine learning is not exactly a suitable application for this task. And for the other options like predicting if a stock price will rise or fall, so this is certainly a machine learning task. Because it involves predicting the stock price based on either the historical data or from different input features, so which can be done using machine learning easily. Predicting the price of petroleum, again it can be done based on input features. You are predicting the price of petroleum. Grouping mails as spams or non-spams, so it can also be done either, you can do it either using supervised learning algorithms 0, 1 or unsupervised, like grouping mails based on whether it is spam or non-spam. So this can also be done using machine learning. So the only task which is not suitable for machine learning is the option A.
Excuse me, sir.
Yes.
Sir, I have a doubt. For the option D, if they ask whether it's a supervised or unsupervised, which will be preferable?
I mean, in this question it is ambiguous whether this is supervised or unsupervised, but generally in grouping is unsupervised learning, and if you are predicting specific classes, then it is supervised learning. So in this question it doesn't really matter, it is, the option is ambiguous in this case. It doesn't specify whether you are predicting classes like spams or non-spams, or you are just grouping those.
So based on the terminology we can
yes.
identify.
If it involves grouping or clustering, then it is unsupervised. Otherwise, if it is predicting specific classes, then it is supervised.
Yes, sir. Thank you.
Mohammad Arif Ali says, what is the difference between graph theory based and machine learning based approach? Yeah, graph theory based approaches are very different from machine learning approaches. Those are different algorithms where we analyze the structure of the graph, and based on that we try to find out the shortest distance between a certain pair of nodes. And those algorithms are very different from machine learning. In machine learning we try to predict based on the data that we have, training data that we have, and in graph theory it doesn't see any kind of data, it only sees the input graph, analyzes that graph from the source node to the target node or destination node. It tries to find out the shortest path. So these two approaches are very different. Now question 5. So this is on k nearest neighbor. Given below is your data set. So this is the whole data set. x1, x2, these are the two features, input features, and y is the output variable or the target variable that you have to predict. You are using KNN regression or k nearest neighbor regression with k equals 3. What is the prediction for a new input value 3, 2? And Euclidean distance measures are used to find out the closest points. So, this is a numerical question, so it would take some time. Can't we identify the option based on image analysis? Image analysis, if you mean graph, plotting those points in the graph, yeah, that is also a valid approach. Actually, that would be easier in this problem because there are only 6 points are there and the range is not very high for each of the features. So you can simply plot those informally plot those points in a 2D graph, and then for the new point 3, 2 find out the k nearest neighbors and compute the y value for this point. Tamil Selvi says 2.5, Shubhrangshu Mohan says 3.1, Sachin Thorat says 2.5, Jayant Manne says 2.5, Bappi Saha says 3,3 or 2,2. Krishna Varanasi says 2.5, Aditya Kirat says 2.5. Pradeepa Ramachandra says 3.67, Saurabh Sehgal says 3.5, Mounes says 3.17, Narmada says 3.8. Okay. Niranjan Murthy says 2.5, Hariharan says 2.583, Nisrin says 2.5. So this question is slightly lengthy because you have to compute a lot of things here. So I will show you the steps. So there are two ways you can solve. The first way is by computing the Euclidean distance between the new point, which is 3, 2, and each of these points. So there are 6 points. So find the distance between 3, 2 and this 2, 5. So this is the first point. So find the Euclidean distance between these two. So Euclidean distance you can find out, so it would be 3 minus 2 whole squared plus 2 minus 5 whole squared, square root of that. So it would be 1 plus 339 square root of 10. So this is the distance between the new point and the first point. Similarly, you have to find out the distance between the new point and the second point, which is 5, 5. In a similar way, you have to find out the Euclidean distances. So now for the second point, it would be 3 minus 5 squared plus 2 minus 5 squared, so it will be 4 plus 9, so it will be square root of 13. So you have to check those calculations whether these are correct or not. So for each of these points, you have to find out the distance from the new point 3, 2. Then for KNN regression, you have to find the k nearest neighboring points of this new point 3, 2. So if you find those 3 points, now you have to take the average of the y values of those 3 points. That would give you the y value for the new point 3, 2. So this is the first approach, that you have to compute all those values. But for this question, the feature values are all integer values and the range is not very high. So we can simply plot these points 3, 2, 2, 5, 5, 5 on a 2D plane, and 2D plane, and then we from visually we can find out the nearest k points of the new point 3, 2. Here k is 3, so 3 nearest points of the new point you can visually find out from the graph, and then just take the y values of those 3 points and take the average of those y values.
Sir, can you once again explain how to find the 3 nearest points?
So first approach is by computing these Euclidean distances. New point is 3, 2. So new point is 3, 2. So from 3, 2, first you find out the Euclidean distance between 3, 2 and 2, 5. That would give you some square root of 10, I think. Most probably you have to calculate this and check. Then you have to find out the distance between 3, 2 and second point, which is 5, 5, and that would give you, I think, square root of 13. Then distance between 3, 2 and 3, 3, that would most certainly give you 1. Then the distance between the new point and the fourth point, distance between the new point and the fifth point, and the new point and the sixth point. So you will get these Euclidean distances, square root of 10, square root of 13, 1, and so on. You will get all these Euclidean distance values. Now for k equals 3, you will take 3 nearest neighbors. So nearest neighbors basically means Euclidean distance would be the least. So based on those distances, you pick the 3 nearest points of the 3,
Can you give the solution for this particular problem? Which are the 3 nearest neighbors?
Yeah, so I have solved it. I have shown it visually. So either you can compute those Euclidean distances, but in this case the points are integer valued points, the features are integer valued, and also the range is not very high. So we can simply plot these points on this 2D graph. So this is the new point for which we want to predict the value of y, 3, 2, and these green points are the training data points. 6 points are there. So visually we can easily see that this is one nearest neighbor, this is one nearest neighbor, this is one nearest neighbor. So k is 3 here. So we have to just find out 3 nearest neighbors. Visually we can already see that these 3 are the 3 nearest neighbors. If it is not possible to visually find out, then you have to compute those Euclidean distance values. There is no other option. But in this case there are only 6 points. You can easily find out the closest points. Yes?
Sir, after computing the Euclidean distance, the least 3 values should be taken, sir?
Yes, 3 closest points should be taken. So 3 least Euclidean distance valued points have to be taken. So these are the 3 nearest neighbors. Now,
sir, in which case will we be taking the maximum value?
No, maximum value is not needed. I mean, here we want to predict the value of y of a new point. So we are only concerned with the values of its neighboring points. So that's why you have to pick only the points which are closest to it, so least Euclidean distance.
Yes, sir.
So these are the 3 closest points. So take the y values of these 3 points. So these are the 3 points, 2 comma 2, 3 comma 3, 4 comma 1, which we can see from this table. So 2 comma 2 y value is 2, for 3 comma 3 y value is 3, and for 4 comma 1 y value is 2.5. So these are the 3 y values of the 3 nearest neighbors, 3, 2, 2.5. We just have to take the average of these 3 y values.
Sir, on what factor you're saying only those 3 are nearest?
Knn, so knn with k equals 3. The question itself states that we are predicting the you are using knn regression with k equals 3. K can have any value in the question. It can have 4, 5, 6 or 1, 2 also. In this question we want to find out the output of the new point only based on the 3 nearest neighbor. That's why k equals to 3.
So it should not be greater than 3.
No, it can be any value. It can also be all 6 values. 6 points are there, k can also take 6. It is a hyperparameter of your model. You have to choose it. I mean, in this question it is given k equals 3, so we will use k equals 3. So it can take any value from 1 to n.
Like you took 2.5, 2 and 3, no sir. Only why did you take those 3?
No, k is number of nearest neighbors that we want to take. Question is that, so you can change the question in the middle of the question. So k is 3, so 3 points. It cannot take fractional values. Knn is k nearest neighbor. I think it has been taught in the class, or is it not taught in the class yet? Because there is a similar question in the first week's assignment, isn't it? Yeah, there is a question. There are 2 questions on knn, one on knn regression, one on knn classification. So I
have another doubt, sir.
Yes.
So while taking the average of these 3 distances, should we take the average of the distances that we obtained or the y value?
No, y values. Distances are only to find out the closest 3 points of that new point. Once we get those 3 closest points, after that the distances don't matter. Now you just have to take the average of the 3 y values.
Yes, sir. Thank you, sir.
So is it fine? Is there any doubt?
Sir, I have a doubt.
Yes.
Sir, using Euclidean distance, I have found out the values like root 10, root 13,
Yes.
root 1. Now, how to find the nearest 3 neighbors? I don't understand that.
Nearest means the distance would be the least, isn't it?
Yes.
So from the 6 Euclidean distance values you would get for 6 points, you have to take the 3 smallest values of Euclidean distance. There would be the 3 nearest neighbors.
The values coming are 1, 1 and root 2. 1 for 2, 2, 1 for 3, 3, and root 2 for 4, 1.
Yes.
So
yes.
these are the nearest points. Other points are root 10, root 13 and 3, which is far away.
Yes. Yeah. So you have to find out the Euclidean distance and take the 3 closest points.
So in case of 2 distances having 2 same, like root 10 is occurring twice, what should we do in that case?
So in that case, generally you can take either one of them, or some specific criteria would be mentioned in the question that if this happens, which point do you have to pick. Generally in the questions it would not occur that more than one point would have same Euclidean distance. Then it would be ambiguous whether to take the first point or the second point. So some criteria would be mentioned, otherwise such case would not occur in those problems.
Yes, sir.
Probably, Ayan,
yes.
In that case, when root 2, root 10 are same, but you can see the y, which value of y is minimum. Whether we can take that, we can go with that approach or.
Generally, I mean, those two might be conflicting in some cases. That, for example, let's say this is this plus 1. This, I mean, in this case, okay. In this case, these are these are class values, continuous values, not the class values. No, I mean, some specific criteria has to be mentioned. Otherwise, you can take any one of them and you can get a different answer. In case of classes, it can be conflicting. Plus 1 minus 1, it can be conflicting if we take different point. But in case of this continuous valued y, some different y would come if we pick a different point. So in this problem, this didn't occur. Most probably, most of the problems that you will be given in the assignment or the exam, 2 points would not have same Euclidean distance.
Okay.
Now question 6. Which of the following is an unsupervised task? Predicting the price of a house based on its area and location, grouping customers based on their preference and history, grouping of handwritten digits from their images, predicting the time in days a PhD student will take to complete his or her thesis, and fifth option is all of the above. So you have to find out unsupervised learning task, and multiple options may be correct in this question. So Vrangsu says BC, Nisrin says BC, Bapi Saha says BC, Niranjan says C, Tamil Selvi says BC, Anantapalli says BC, Shraddha says A, Anusha Gupta says C, Publius says BC, Narmada says B, Pradeepa says B, Akshara says C, Sunirmal says BC, Hariharan says E, Navami says BC, Yash Mehrotra says BC, Satish Singh says BC. Okay, so the correct answers are B and C. So as I have already mentioned in some of the previous questions that in unsupervised learning problem or unsupervised task, you will be asked to group the samples based on some features. So grouping is unsupervised learning problem generally. So here also grouping customers based on their preference, it is an unsupervised task. And grouping of handwritten digits, it is also grouping or clustering of the digits, so that is also an unsupervised task.
Sir, predicting will be supervised, no? Sir.
Predicting is generally supervised, whether you are predicting a specific class or whether you are predicting a specific target value. In that case, it will become supervised.
So actually this problem we can solve as A and the D also we can make it unsupervised, no, by not giving the map. I mean, we can make it learn by itself.
No, I mean, predicting the price of a house, you need to have the Y values in the training data. Otherwise, how would you predict? The machine needs to learn from the past data, isn't it? That these were the Y values in the training data. So based on that, for the new data point, what will be the Y value, price of a house?
Okay.
Sir, I have a doubt, sir.
Yes.
Suppose the question is asking us to sort some items. So suppose the question asks us to sort some.
1 minute. Hello. Hello. Yes. Yes. Yeah, I'm conducting the live session right now. no, I mean there is a limit of 100 students, so many of them are not able to join. So I cannot do. Some students also told me that some of the students, their friends are waiting, but no, it's going on. Yeah, there is a limit. So yeah, yes. And there are 100 students are there. Some of them are leaving, then some more students are joining, but it is always at 100. Yes. Yes. I'm recording, and after this session, I will also upload it. Hello. Yes, Sweta, you were saying something?
So suppose the question asks us to sort a set of items based on titles. Will it be supervised or unsupervised?
Sorting.
Sorting a set of items based on their titles.
Sorting is not a machine learning task, isn't it? Sorting, there are different algorithms for sorting. You wouldn't use, generally you wouldn't use machine learning for sorting, isn't it? Machine learning
Yes,
is
sir,
not
but
really suitable for sorting numbers or data or anything.
can we associate sorting as grouping?
No. Grouping doesn't have any sorting capability in it. Grouping is basically a set of points which are similar, another set of points which are also similar in a different way. So different groups would be, or different clusters would be created in unsupervised learning problems, but those points would not be sorted in any way. So once you will be taught these unsupervised learning algorithms like clustering algorithms, then you would understand k-means, and there are many dbscan, many clustering algorithms are there. You would be taught all these topics.
So how about the generative problems? That is also supervised or unsupervised?
Generative can be both ways actually. Either you based on your own generative data that you learn, or otherwise if you have some past data from which you are learning, then it becomes supervised. Generative learning can be done in both ways, so that is a completely different topic.
If there is some data from which you are learning, it becomes supervised.
Yeah, not just data. I mean, unsupervised learning problems also learn from data, but they have those target class levels, or the target variables, y value specifically, have in the training data.
Can you explain me option C, sir? I can't understand.
So 1 minute, sir. So can we tell that the terminology sorting is not used in machine learning?
Sorting is a different kind of there are different algorithms for sorting, but machine learning is not suitable for sorting.
So if there is a question regarding that, we can ignore the options, sir.
Yeah, I mean this based on the context of the question. I don't know what the question is, whether that is in the assignment or not. If it is in the assignment, I cannot discuss that question right now before the deadline is over.
Yes.
But sorting is not suitable for machine learning generally.
Yes, sir. Thank you, sir.
So someone was asking about option C.
Yes, sir, I am on.
Yeah, option C, grouping of handwritten digits from their images. So images would be given for different handwritten digits. Now you have to group them based on similarity. So any kind of grouping is unsupervised learning. You are not specifically predicting whether this handwritten digit is 0 or 1 or 2 or 3. You are not predicting what digit it is representing, that image is representing. You are just clustering or grouping them based on similar features. If it was predicting the handwritten digit from the images, then it would have been a supervised learning problem. But here grouping is not same as predicting. Sorting a set of news articles into 4 categories. That sorting is different. I mean, yeah, Shweta was asking about sorting objects. Sorting basically means in some order, which we use in computer science 0, 1, 2, 3, 4. This is sorting in the ascending order or sorting in the descending order. But in this case, sorting a set of news articles, that is completely different from sorting based on a specific number. But I cannot tell you the answer right now because that is already in the assignment. So after
Sir,
the
no need to tell the answer, sir, but can you just tell that it can be categorized as supervised or unsupervised, sir?
I mean, that is in the question, isn't it? You have to find
Sir,
out
no,
whether this task is supervised or unsupervised. That is the question in the assignment. I cannot tell you
sir,
the answer
because
right
you
now.
told me that sorting cannot be.
No, that sorting, what I was thinking was different. Like sorting is
Yes, sir, yes, sir.
sorting in the ascending order or sorting in the descending order. That is completely different from the sorting news articles into 4 categories. Sorting here basically means dividing it into 4 news articles into 4 categories.
Yes, sir, yes.
That is these two sortings are different. So I didn't understand your question that time, but right now I cannot answer this question because it is in the assignment. Okay, so moving on to question 7. Let x and y be a uniformly distributed random variable. Let x and y be two uniformly distributed random variables over the interval 0, 6 and 2, 8 respectively. So this interval is for x, this interval is for y. If x and y are independent events, then compute the probability of minimum of x, y less than equals 4. So x is taken from this uniform distribution 0, 6, y is sampled from the uniform distribution 2, 8. Now you have to find out the probability of minimum of x, y less than 4. This problem is slightly difficult, so I will just show you the steps how to solve it. So we have to find out probability of minimum of x, y less than 4. So minimum of x, y less than 4 this event can be rewritten as probability of x is less than 4 or y is less than 4. If x is less than 4 or y is less than 4, then minimum of x and x, y would be less than 4, isn't it? So if any one of them is less than 4, then certainly minimum of these two elements should be certainly less than 4. So we can break down this minimum of x, y less than 4 into two separate events, x less than 4 or y less than 4, and we can rewrite it using union. So or can be replaced by union in case of probability. So these are the two events, x less than 4 and y less than 4. So we have to find out the probability of the union of these two events. So probability of A union B, we can write it as probability of A plus probability of B minus probability of A intersection B. So this is one event, this is another event. So now this intersection, these two events x less than 4 and y less than 4 are independent events. So independent event, that means we can write this intersection as simply the product of their individual probabilities. Now we have to find out probability of x less than 4, probability of y less than 4, and also the product of these two. So probability of x less than 4, x is from 0 to 6, uniformly distributed from 0 to 6. So probability of x being less than 4 is certainly 4 by 6. It has a range of 6, but it can take only values from 0 to 4. So probability of x less than 4 is 4 by 6. Similarly, probability of y less than 4, y is sampled from this range 2 comma 8. So let's say this is from 2 comma 8 and here is 4. So y has to be less than 4. So y can be picked only from this region. So this region is of length 2 only, from 2 to 4. So the length of this region from where we can pick y is 2, but the whole range is of length 6, 2 to 8. So 2 by 6. Now we just have to put these values 4 by 6 and 2 by 6 into this expression.
Excuse me, why this is 6? Because it is inclusive both, right?
Inclusive, but it is not integer values. These are continuous values.
Okay, okay.
In case of continuous values, 0 to 6 basically means 6 minus 0 is the total range.
Okay, okay.
2 to 8 is 8 minus 2, but if these were integers, then it you have to include 2 and 8, then it becomes 7 in that case.
Yes, got it.
Why is it a 2 by 8, sir?
Which one?
Why it isn't 2 by 8, sir?
No, the range is 2 to 8 for y, isn't it? So y can take values from 2 to 8, but I want to find out the probability that y is less than 4. So this is 2 to 8, this is the total range of y. Here is 4, y can be less than 4, so y can be in this region only. So width of this region or length of this region is 2 and length of the whole range is 6, isn't it, from 2 to 8?
Yes, sir, yes.
So 2 divided by 6, out of 6, length of 6 we can only pick it from the length of 2, so 2 divided by 6. Similarly for x is less than 4, 4 by 6 it would be. Then you just have to put these values here in this expression.
Excuse me, sir, why you are not taking real values, sir? 0, 1, why integers alone?
No, I mean in this question specifically it is for real number values, continuous values. So if it were for integer values, it would be different.
Real number value, floating point number you won't take. Only whole numbers, you are taking only whole numbers, right? Not real numbers, right?
Now, here it can take only real numbers, but if it were for integer, sorry.
Why are you taking the numerator as 4 there and y less than 4, y 2 alone you are 2 to 4 I understand, but 2 and 3 and 4 but it can be various values, right? 2.1, 2.2, 2.3.
Yeah, that is why these are continuous probability values, isn't it? These are not discrete probability. In case of continuous, it can take any value between the range 2 to 8. Y can take any value in this range 2 to 8. You can get 2.99999. It can take any value.
Right, it can be any value, right? But 2 to 4 also it can be any values, right?
Yeah, that's why 2 to 4 this length. I mean, if you have any confusion regarding the probability, you can see the basics in the internet. But in case of continuous, you have to, for single variate events, you just have to find out the length which is valid divided by total length of the range. Here it can take values in this range only.
1 by b minus j, what is it's a area under curve, that's going to be the...
Yeah, area in case of if it is a 2D plane, here it is 1D straight line, is the x and y values are on 1D straight line, isn't it? So you just have to take the length. Area, when it is a 2D plane, so you have elements distributed in the 2D plane. Here these are points are distributed only on 1D straight line. You have to take the length basically. Instead of area, you have to take the length. Here the if y is less than 4, it can be in this length only from 2 to 4, but the total range is 8 minus 2, which is 6. So, this is for continuous probability values. If it was discrete, it would be different, and in case of continuous probability, if it is a 2D plane, you take the area, the allowed area for which the variable is valid. In this case, the length of the range for which it is valid.
Thank you, sir.
Sir, can you say how did 4 by 6 come?
4 by 6 again, so from 0 to 6, this is the range for x, but I want to find out probability of x less than 4. So, x can belong in this range only, isn't it? 0 to 4. So, length of this is 4 and length of the total range is 6. So, this is 4 by 6. It can take any value between 0 to 4, that is the permissible limit of the values for x less than 4, and the total range is 6.
Sir, how do I get 2 by 6 once?
2 by 6 I have written here, I will show you once more. 2 to 8, this is the total range for y, and here is 4. I want to find out the probability that y is less than 4. So, y can take values in this range only, 2 to 4, isn't it? So, length of this permissible range is only 2, but the total range is 6. So, the probability would be 2 by 6.
Okay, sir, thank you.
Sir, 2 to 4, we have 3 points, no, sir? 2, 3, 4.
These
points.
are continuous values. So, this is not for integers. So, for continuous probability, you have to take the whole range, not specific discrete values like 2, 3, 4, not like that. The whole range you are taking. It can take any value 2.1, 2.35, like that.
So, for that case, only we can consider only 2 and 4 two values.
No. We are not taking discrete values. We are taking the range. The length of the range from 2 to 4 is 2.
How you can say like that? 2 to 4? 4 to 2 is the length 2?
Yeah, length of the range for which we are trying to find out the probability. Y is less than 4, so y can take value, any value between 2 to 4.
Yes, sir.
So, the length of the permissible range is 2, but the whole range is 6. So, that is why 2 by 6.
Sir, for continuous real values, how we write this, like just 2 upon 6?
So, for continuous values, if it is a 2D variable, then you have to find out the area for which it is allowed. In this case, these are 1D values, both x and y. So, you have to find out the length of the range for which the event is valid, x is less than 4 or y is less than 4. So, the y is less than 4 basically means y can take value from 2 to 4, any real value from 2 to 4. So, that length is 2, but the total range for y is 6. So, it can the probability that it is less than 4 would be 2 by 6. That is basically 1/3 of the total probability.
Excuse me, sir. How do you say it's one dimensional or two dimensional? How to distinguish that?
No, I mean distinguish. It is written that it is in the interval 0,6. So, basically in 1D, once the straight line we are talking about. These are univariate random variables. So, it is on the 1D straight line, not on a 2D area.
And what is P intersection B here?
This one?
Intersection.
So, intersection, both the events are independent, x less than 4 and y less than 4. So, we can split the intersection just as multiplication of the two individual probabilities, p probability of x less than 4 into probability of y less than 4.
What if x and y are not independent
I couldn't understand your question. Independent events you're talking about?
What if X and Y are not independent events?
So in that case, you need to have the probability of x, y. This value you would also require, but that would make this question much more difficult. So they are independent. So probability of x less x y is probability of x into probability of y. You can simply take the product of the individual probabilities to find out the probability of the intersection. But if those two events were dependent events, then it would be different. Calculations would be different, and you would need this probability also, probability of x intersection y. But that would make this problem much more difficult, and I think in this context it would not be, we will not be able to solve it. We would require some extra information, I think.
Excuse me, sir. I am Ashwin. Could you please share the WhatsApp group link in which the notes are shared?
Yeah, notes and the recordings would be shared later. So that will be shared with all of you from NPTEL team. We will upload this in YouTube, and also the slides would be uploaded, and NPTEL would share with all of you later on.
Sir, is there any WhatsApp group or something?
No, we don't have any official WhatsApp group like that.
Okay, sir.
So if you compute the value, it would come out as 7 by 9 by plugging in all these probability values here. Question 8. Which of the following is an unsupervised learning task? Multiple options may be correct again. Predict the stock market price of a company, predict rainfall for a given day, predict flowers based on similar features, predict whether an image contains a dog or a cat. So all of you are writing option C. So unsupervised learning problem involves grouping or clustering objects. So option C is the correct answer. The other three are predicting the stock price, which is certainly supervised learning problem. Predicting rainfall is also supervised learning problem. Predicting whether an image contains dog or a cat, this is also supervised learning problem. So the only problem which is unsupervised is grouping flowers based on similar features. Now question 9. Which of the following is a reinforcement learning task? Multiple options may be correct. Learning to swim, learning to predict weather, learning to play a video game, learning to group similar flowers based on features. Yeah, most of you are saying option A and C. Some of you are saying A, B, C. Yes, so correct answers are A and C.
Can you please say what exactly is reinforcement learning? I'm having a doubt.
Yeah, so in reinforcement learning, you learn by trial and error. So, for example, learning to ride a bicycle, you don't have specific y values or actions that are given to you, that if it is at a certain angle, if it is this state of your body, then you should do this, you should steer your bike this way or that way. So these values are not given to you. How you learn is that you start by trial and error. You start by pedaling and you fall, then again you go up and you start to rotate the steering pedal in some different way so that you stay up. So you learn by trial and error. You get reward signals from the environment based on how good you are doing. If you are able to ride the bicycle in a proper way, you are able to go in a straight line and you are able to stay right up. So that is a reward signal that you are able to do well. So you try to imitate that more and more, so that you stay right up. So that is
how learning to swim is considered as reinforcement.
Yeah, learning to swim is also like that. You don't have specific actions told to you from some past data or training data that if it is how you are doing, you should do this. You don't have any such specific data. You learn to swim based on your past experience, based on the environment and based on trial and error. You try something, it doesn't happen, you try something other, based on that you learn. Basically you take at a given state, you take some action, based on that action you get some reward from the environment. If you are doing well, you get a positive reward, and if you are not able to do well, you get a negative reward or penalty. Based on that you try to adapt your actions. So any such task is which can be learned by trial and error, and rewards from the environment is a reinforcement learning task. But the other two options, the weather, predicting weather and grouping similar flowers, this cannot be done in this fashion, that you do something and the environment gives you some reward, based on that you adapt it. Predicting weather, you need to have the y values, and based on that training data you try to learn what should be the y value for a new data point. Similarly, grouping flowers, based on the input features you group those flowers. You cannot form it as a reinforcement learning task.
So there are some problems which can be done both as supervised and unsupervised. No, how do you select which one to take in that context actually?
Yeah, some problems can be done in both supervised and unsupervised. There is also a method called semi-supervised, where we combine both the approaches, but that is I cannot think of any such example right now, but there are problems which you can do.
Sometime back, suppose there's some data from which you are generating something new. So in that case, do you call it like a supervised or an unsupervised way? And okay, suppose you have to solve a particular problem also, and you can do it both in the supervised and unsupervised way. How will you select which one to use?
Yeah, if there are both ways present, then supervised is much better. Supervised because you have the supervision of the y values, so you'll be able to learn much better way and much quickly, because you have the y values.
For generative, do we say it is supervised or unsupervised, because it is bringing out something new also? No?
Yeah, and generative can be done both the ways. It can learn without any class or target variables given, or it can learn from the target variables. It can be done in both the ways.
Actually, one question in the assignment also, it was confusing. That's why I asked, because which one to select, I did not know.
No, it is based on the context of that questions, and also I cannot answer it right now. If you have any doubt regarding those questions, you can ask in the discussion forum. There the official TAs and the instructors are able to clear your doubts regarding the questions. After the assignment is over, deadline is over, then we can discuss, but before the deadline is over, we cannot discuss this.
So here the option B is because it is a prediction is a supervised learning, even though it is a learning. That's why it is not picked. And also option D, grouping means a categorization. Again, it is considered a supervised learning, correct?
No,
sorry,
I mean if you already have specific categories of flowers, that this is flower 1, these are flower 2, these are flower 3, then it is supervised. But if you just have to group the flowers, you don't have the specific categories, then it is unsupervised.
Okay. So in this case, is it supervised or unsupervised?
In this case, grouping is generally unsupervised. That you are not predicting specific y values, you are just predicting this is cluster 1, this is cluster 2, this is cluster 3. If there are 3 clusters or groups, you are not predicting that this is this flower, this is that flower, this is some other flower. You are not predicting the specific categories. And in the training data, if you don't have those y values, then it is certainly unsupervised learning task.
Yes, sir.
Mohammad Abdul Qadir says, can we say learning any game or sport is learning any game or sports is generally reinforcement learning, because you don't have specific y values to you available. You learn by trial and error. You do something, you fail, you try something other so that you succeed. So based on trial and error and the reward that you get from the game or the sport, you try to adapt your actions. Question 10. A bag contains 2 red, 3 green, 2 blue balls. 2 balls are drawn at random. What is the probability that none of the balls drawn is green?
Sir, with replacement, without replacement?
It is without replacement. You are picking both the balls at the same time. So after that you would have 2 less balls in the bag. So without replacement. Arbaz Pathan says option D, Mounes says option C, Tejasvi says option C, Sachin says option D, Pablo says D, Pradeepa says B, Nami says A. Okay, I have received different answers in the chat. So to solve this problem, so we are picking 2 balls without replacement, and probably that none of the balls drawn is green. So basically we are picking from these red balls and blue balls. So in how many ways we can pick non-green balls? So there are 4 non-green balls available, so number of ways we can pick is 4C2. 4C2 is the number of ways we can pick 2 non-green balls. And how many ways can we pick any 2 balls of any 2 colors? So there are total 2 plus 3 plus 2, so total 7 balls are there in the bag. So the number of ways we can pick any 2 balls is 7C2. So that is the sample size to us, 7C2, and number of ways we can pick 2 non-green balls is 4C2. So the probability would be 4C2 divided by the sample size, which is 7C2.
How did 4 come, sir?
So we have to pick non-green balls. So there are 4 non-green balls, 2 red and 2 blue. So out of these 4 balls we can only pick 2. So number of ways we can pick 2 non-green balls is 4C2. From 4 we are picking 2. And there are 7 balls in total, so how many ways we can pick 2 balls from all the 7 balls is 7C2. So that is our sample size. So that would go as the denominator, and the numerator of the probability would be 4C2. How many ways that event can happen? Event here is picking 2 non-green balls. And if you simplify this, it would be, I think, 6 divided by 7C2 is 7 into 6 by 2, which is, it would be 2 by 7, option C. Is there any mistake in the calculation? I think it is right. 2 by 7. Someone said it would be option D. So it will be 4C2 divided by 7C2, and 4C2 is 6, and 7C2 if we calculate it would be 21. 6 divided by 21, and simplifying it we would get 2 by 7. So correct answer is 2 by 7. Now question 11. Which of the following are false about bias and variance of overfitted and underfitted models? Again, multiple options may be correct. Underfitted models have high bias, underfitted models have low bias, overfitted models have low variance, overfitted models have high variance. Multiple options may be correct. Nisrin says AD, K Samapada says AC, Renuka Sharma says AD, Dr. Sunirmal Khatwa says AD, Narmada says AC, Khushbu says AC, Praveen says BC, So most of the answers are A and C. So you have to find the false options here. So mind that part of this question. So generally overfitting is associated with low bias and high variance, and underfitting is associated with high bias, low variance. So based on this we can see that first option says overfitted models have high bias, overfitted models should have low bias, so this is false. And option B says underfitted models have low bias, this is not false. Overfitted models have low variance, this is false, so this will be correct. And overfitted models have high variance, so this is actually correct, so this is not false. So false options are A and C.
Sir, I have a doubt.
One moment. It shouldn't be A. So underfitted models have high bias is actually correct. The false is underfitted models have low bias. That would be the false option. Yes, someone had some doubt.
Yes, sir. Sir, what is this term mean? Overfit, underfit, bias, variance?
These are taught in the week 1 lectures, isn't it? So there is a specific video on bias variance trade-off. This is almost 1 hour lecture you can go through. Generally bias is basically how much your prediction is deviating from the actual value of the target variable, basically error. And variance is how much your what is the variance of your own prediction. So basically sensitivity of your prediction of your model. So these are informal definitions. You can go to those video lectures there. Bias and variance are formally defined and also mathematically defined there. And overfitting basically means when the bias or the error would be low, but the model becomes so complex that variance becomes high. For very small changes in the input, the output fluctuates a lot. So the variance of your output becomes very high. In case of underfitting, your model is not trained properly, so the bias error is very high. Your predictions are far away from the actual target value, but variance would be low. So the model is not very simple, not very complex, so the variance or the sensitivity of the output of your model is very low, so variance of the output is low. So that is underfitting. These two terms and bias and variance are defined in the video lectures formally. You can go through those lectures. So B and C are the two correct options. Now question 12. You are given a set of 2D points and their class levels. So these are the 2D points. x1, x2 are the two features, 1, 1, 6, 2, 3, 7, 8, 6, 2, 4, and class levels are also given for all 5 points. Using k nearest neighbors algorithm with k equals 3 and the Euclidean distance as the distance measure, determine the class level for a new point 4, 4. So this question is also quite lengthy. I will show you the steps how to solve it. So these are the training data points. 5 data points are given and their specific class levels are given. So in the previous one of the previous questions that we solved on KNN, that was KNN regression. So the output variable or the y values, so these are the y values, those were continuous values. So that's why that problem was regression problem. but here these are class levels, +1 or -1, two classes are present. So this is a classification problem, and so this is the new point 4,4. So you have to find out the Euclidean distance from 4,4 to 1,1, 4,4 to 6,2, 4,4 to 3,7, 4,4
Sir,
to 8,6.
the previous problem was regression problem, sir.
Yes, the previous one was regression, KNN regression, and this is KNN classification.
So how to identify the regression or classification, sir, in a problem?
So regression, the y values, these are the y values. So y values will be continuous variables. There it was 2, 2.5, 3, something like those. But here these are class levels, only two possible classes, +1, -1. It is specifically written that these are class levels. Class basically means that cannot take continuous values. There are only finite number of specific classes present. In this case, two class, +1, -1, there can be 3 or 4 or any number of classes, but that has to be finite.
Sir, so class labels terminology is present means it is classification.
Yes.
Sir?
So from 4,4 you have to find out the distance with each of the training data points to 1,1, 6,2, 3,3, 8,6, 2,4. So you have to find out the Euclidean distances and then pick the 3 closest points. Here k equals 3. So generally speaking, k nearest neighbors you have to pick. Here k equals 3, so you have to pick the 3 nearest points of 4,4. And the majority class of those 3 points would be the class level of your new point. So if you compute the distance values, I hope these calculations are correct, you can cross check it later. So these are the distance values, Euclidean distance values from 4,4 to each of these points, 4.24, 2.83 like this. So 3 closest points would be the 3 points to the least distance values. So there would be this is the closest point or nearest point, this is the second nearest point, and this is the third nearest point with the 3 least values, Euclidean distance values. So 2,4, 6,2, 3,7, these are the 3 nearest neighbors of the new point 4,4. So what are the class level values? So this +1, +1 and -1, +1 and +1. So we can see that -1, +1, +1. So majority class here is +1. There are 2 +1 points, 1 -1 point among the 3 nearest neighbors. So majority class would be +1. So that would be the class of the new point based on CNN. Yes.
So if the k is given as 4 and there are class labels 2 are equal and another 2 are equal, which option should we choose?
Yeah, that is ambiguity in the question. In that case, I mean, you can choose any of the other 2 points, and those 2 might also be conflicting. If you take the first point, it might give you majority class of +1. If you take the second point, it might give you -1. So that is ambiguity, but generally in these problems such ambiguity would not be present, otherwise you would not be able to write the correct answer. In this question, 3 is k equals 3, so odd number is given, so you will never have such a problem. And also distances are completely different, all the distances are completely different here, but if the distances are same, then you can pick either of them, but generally in such questions distances would be different.
Yes, sir. Thank you.
So majority class you have to pick, which would be +1 here. Your voice is breaking a lot. I can't hear you properly. I can't hear you. You can write your question in the chat.
In the previous example, we have taken mean in the similar problem. But here we are not taking mean.
Yes, so the previous question was regression. So y does not take specific class levels or categories. Y can be any continuous value. So for the nearest point we take the average. Here it is a classification problem. There are only 2 classes present, +1 and -1. So majority class would give you the class of the new point. because the class cannot be any continuous value. If you take the average, it would give some continuous value if you take the average of 3 classes here.
Sir, excuse me, sir. I mean to say K nearest neighbor is always a classification problem. K means clustering only. It's a
no. KNN can also be used for regression. I mean, there is already a question I have seen in the assignment 1. I think if someone can write in the chat if yes or not, but I have seen one question, because KNN can be used in both the cases. KNN basically means you are finding out K nearest neighbors. After that, what you do is based on you. You take the nearest neighbors, and the nearest neighbor basically means those points are similar to the new point. Now, if the y value is continuous, we will take the average of the y values, and if the y values are class level values, then you take the majority.
Right, I got it. Supervised learning algorithm.
Yeah, supervised can be either regression or classification, but KNN is a supervised learning problem always.
Actually, I have a doubt regarding question 10 that was on probability. The questions are over, no, for today?
Yes, the questions are over.
Before to that question 10,
yes.
See, for example, instead of label mentioned as -1 and +2, let's say it is mentioned as A and B. Possible, no?
Yeah, again, same thing. I mean, +1 -1, you just have to find out the majority class among the three nearest neighbors here. It can be the +1 can be A, -1 can be B.
Correct.
So B, A. So these are the 3 closest nearest points. So majority class, there is 1 B and 2 A's among the nearest neighbors. So A is the majority class.
Sir, can class labels be more than 2 variables?
No, it can take any finite value. Class labels can be 10 classes. If you are predicting the handwritten digits can be from 0 to 9. So there can be 10 different classes.
So if there is a tie, how will you predict the class?
There is a
tie, equal number of nearest. So it
in
won't
that
be
case, yeah, you can predict it either as +1 or -1.
Generally, because number, your K is always odd, no? So it's okay.
Yeah, generally K value of K is taken as 1 because taken as odd because it would not cause some problem like that. But
that is when there are even number of classes only. Suppose it's an odd number of classes also, then it could have a type.
No, odd number of classes can be present in any question. Odd number of classes can be there. A, B, C, there are 3 classes.
So how do you resolve a tie in that case?
I mean, tie can be resolved by taking either of the classes. If there are three-way tie, you can pick any of the classes, but generally in these questions, such ties would be avoided. The question would be created in such a way that those ties don't occur.
Okay, and one more thing, sir. Actually, that question number 10, could you please take? Actually, I did it in a different way. I wanted to know what is wrong, that is all. Because, this one. What I did is like, first we have 3 out of 7 green balls. And then in the second time you will get 2 out of 6 green balls. Suppose the 3 ways of taking, both can be green. First one can be green or second one can be green. So like that, when I took and added the probabilities, for it not to be green, I was getting only 1/7. But here the answer was 2/7. That's why I was confused.
It is easier to do it from non-green point of view. That there are 4 non-green balls. 4 non-green balls are there. From those 4 non-green balls, you are picking 2.
No. Whatever you said, I completely understood. But this one doubt, what I did is, like, I took 3/7 into 2/6 as the probability for 2 green balls. Then 3/7 into 4/6 for the first one as a green ball. And 4/7 into 3/6 as the second one as a green ball. So, and when I added up all that, I was getting 6/7. So I thought 1/7 is the probability that none of the balls is green.
No, there are, okay, so for example, 3/7 into 2/6 is both the balls are green.
Yeah. Second, and if the first one is alone green, it will be 3/7 into 4/6.
3/7 into 4/6 plus,
third one is 4/7 into 3/6.
4/7 into 3/6 basically means first one is the order doesn't.
Second one alone
These events, these three events are not exactly, I mean these two events specifically are not completely independent, because we are not bothered about whether we are picking a non-green ball first or a green ball first. So
No, but
there will
when
be
you do
some intersections here.
when you do that 4C2, that will come, no?
No,
One
4C2 is picking any two ball. Order doesn't matter whether we first pick the green ball, then
Oh,
pick
so that-
non-green, or first pick the non-green ball, then pick the green. Here the orders are specified, so these two events are not exactly independent. So you cannot simply add these two.
Okay, but I thought they're independent only, no? Why should they not be?
Yeah.
Sir, excuse me, sir. I have got this one, sir. At the first there are about 7 balls, right, sir? And they are picking non-green balls is 4 out of 7. That's the first event, right? Next event it's going to be 6 balls, and we are going to pick only 3 out of 6.
Yes.
It can be 3 out of 6. So it can be like that also, sir. It can be like that.
Yeah, that can also be done. 4, you are picking 4 divided by
7 into 3 by 6 can be there.
4 divided by 6 into 3 divided by 7.
4 by 7.
Oh, sorry, 4 by 7 divided by 3 by 6. That would give you the same answer, isn't it?
It will give the same answer, sir. I did this way.
Yeah, it will be 2 by 7. Yes. That is also a valid approach. That is actually, I mean, what I have done is similar to this approach, that we are going from the non-green ball point of view. But what Sweta Lasmi is saying, that you are adding 3 different probabilities of 2, I mean the complement, you are computing the complement of the actual event here, at least one ball. So that I think there is these two events are not completely independent. That's why you are getting some extra probability here.
Okay, thanks. So today's session is over, actually.
Yes.
If we want.
Sir, again I have a doubt, sir, regarding that probability of min of x comma y less than 4. There uniform distribution you have told, right, sir?
Yes.
That min of x comma y, and what is y, that so only you take as a integer value, so you take a length.
If they are integer, these are continuous probability values, you can check those continuous probability values. For continuous probability, you have to take the length as the range. Length, not the specific integer values in that range. Any value can be taken, so you take the length. But if it is discrete, then you pick only the number of integers in that range. If you have any doubt, you can search in the internet. There are many materials available on that. But this is the thing that
1 by b minus a, uniform distribution 1 by b minus a, right, sir? 1 by b minus a, right? And you take minimum of x comma y is less than 4.
Yes.
So 0 to 4 you are taking. The length is 4 you are taking, 4 by 6, and 2 to 4, 2 by 6. 4 by 6.
Yes.
But why the 0 to 4 you are taking, right? Why you are not at 0.1, 0.2? Why you are not taking that? Because
it can take any value between 0 to 4. I mean, I cannot explain it properly in this live session, but you can study about continuous probability values, how to compute those probability values if the variables are continuous, random variables. You can study there properly, but if you have to take the length, as the possible number of values that y can take.
No, sir, I need to ask min of x is the length.
Min of
x you are putting, right? Min of x comma y. Min means so you are taking the minimum between 0 and 4.
No, 0 and 4 is not occurring anywhere here. X can take any value between 0 to 6, y can take any value between 0 and 8. Probability you have to x can take one value, y can take one value in this range, and you have to find out probability of mean of x comma y less than 4. So mean of x comma y, mean of x and y.
Min of x comma y. Min of x is less than 4 or min of y is less than 4?
Yeah, this event can be broken down into 2 events. Either x is less than 4 or y is less than 4. So or basically means union. So you take the union of those 2 events, and then union of 2 events you have to find the probability of that.
Sir, for the next session.
Why is it that min given that, sir? What does it mean actually?
Basically means you are picking 2 values, x and y, Now what is the probability that whatever values of x and y you pick, minimum of that is less than 4? This is a specific question that, I mean, it can happen, it can be given in probability and statistics. So you are given two values x and y, you picking from two uniform distributions. Now you have to.
Why is the power of x to come y less than 4? We can't give that. Power of x less than 4 and power of y less than 4. Okay, sir. Right. Thank you, sir. Thank you, sir. Thank you, sir.
Sir, for the next session, will we be continuing with week 1 or week 2, sir?
Next session, I will solve some problems on week 2.
Sir, can we have some problems on bias and variance, sir?
Bias and variance, some problems. I mean, there are so many materials available online. You can just search bias variance trade-off, bias variance in machine learning. You can find a lot of
Sir, can we at least see 1 or 2 problems in next class, sir?
On bias and variance, yeah, I can have 1 or 2 problems if I can
just for
or gather some questions.
Yes, sir. If any doubts are there, so I can clear it in live.
Yeah.
Thank you, sir.
Sir, can you explain the KNN classification and regression once again? I don't understand clearly.
So the basic concept is that in any of the KNN regression or classification problem, first is that you have to find out the k nearest neighbors of the new point given to you. So for that you have to find out the Euclidean distance from the new point to all the points in the training data and take the 3 nearest points. 3 k equals 3 here, so 3 nearest points. So you get the 3 nearest points of the new point. Now for KNN regression, you take the average of the y values of the 3 nearest points, and in case of classification you take the majority class of the 3 nearest points.
Sir, could you show it with the example you solved once again?
This is classification. So from 4, 4, you have to find out the distance between 4, 4 and 1. 4, 4 is the new point that is given to you. Find the distance between 4, 4 and 1, 1. Find the distance between 4, 4 and 6, 2. Then from 3, 7. Then from 8, 6. Then from 2, 4. These are the Euclidean distance values that I have computed. These values have to be computed by you. The Euclidean distance using the Euclidean distance formula. Now these are the 3 points which are closest, isn't it? Based on these distance values. Least distance means it is the nearest or the closest. So these are the 3 points. These are the classes of these 3 points. These 3 closest points. -1, +1, +1.
Sir, will they mention you have to use the distance from Euclidean distance or Manhattan distance or any distance formula? They will mention it or
the distance measure will be mentioned in the question, whether you are using Manhattan or Euclidean or some L1 norm distance. That will be mentioned in the question.
So distance measure, the formula if we use, may result in different.
If you use different learning, distance measure, different answers might come. Yeah.
Thank you, sir. Thank you, sir.
Sir, and regression?
So in regression, you find out the distance values similarly. There is no difference in the distance value computation. But instead of taking the majority class, these y values would not be class levels; those would be continuous values. So in that question, let me go to that question. So these y values were given here: 3.5, 5, 3, 4.5, 2, 2.5. So these are not class levels; these are continuous values. So these were the 3 closest points. And the y values of these 3 closest points were 3, 2, 2.5. So you have to take the average of these 3 y values. That would be the y value of your new point 3, 2 here.
So we will calculate the distance and take the average or the y values average.
Average of the y values. Distance is computed just to get the nearest points, 3 nearest points or k nearest points in general.
Okay, sir.
Then take the average of the y values or take the majority class of the y values in case of classification.
So in both classification and regression, we will calculate the distance to get the nearest neighbors, and then we will perform the operation. In
Yes,
regression, we will average.
perform the operation on the y
classification
values only, not on the distance values. Yeah.
Okay, sir. Thank you.
Sir, when will be the next class, sir?
Next session will be on next Monday again.
Sir, can we get this videos?
Yeah, videos and these slides would be uploaded, and links would be shared with all of you by NPTEL team.
Okay, thank you.
Okay, so thank you everyone for joining. If there are no other doubts, then we can end this live session now.
Okay, thank you, sir.
Thank you. Thank you.
Thank you, sir.
Okay, sir.